Hello students, in this video we'll discuss about how to insert equations along with the symbol definitions and see how to use abbreviations inside the project template that is being shared. So without further ado, let's start with the discussion of how to insert equations. As usual, we first look at the equation enrollment and its associated commands to insert the equation onto the template. Here we have this begin and end equation, and if you are using a text maker as your text editor, then you can use the shortcut key, which is Ctrl Shift and N. So this command in turn creates an equation in a separate line and it appends the appropriate equation number automatically, and we call such equations as non-inline equation. So you might have a thought, then what is known as inline equation? But before we step further into the discussion about the inline equation, I want to talk about few more commands that are associated with this equation enrollment. So as we discussed in the previous videos, the label basically is used to create a reference name for the equation, and we will be using a prefix EQ with colon while defining the reference name for the equations in our project reports. And the ref command, along with the reference name that we have created in the label, returns us a kind of number for us, and which is usually have to be associated with the label. In this case, we'll be using EQ with a dot to assist the reader of your report that the number that appears with the reference command is an equation number. Also note that there is no centering command, as the LaTeX by default puts the equation as center aligned. The next command is a no number. Now sometimes you might have a lot of derivations and you might not want the numbers to appear for every line of equation in the derivation, and in such situation you will be using this command no number between this begin and end equation in enrollment. So next we'll discuss about this inline equation, which is used to write equations along with the paragraph lines and not as a separate line. So the mathematical expression basically appears between this $2 symbol, okay, and whatever we write within this dollar symbol is known as the inline equation. And here is an example where there is some sort of assumption that has been stated that the value of x is equal to 2, and when you compile this particular line, it compiles as this particular form, okay, and the shortcut key to get this $2 symbol is by using this Ctrl Shift M key. So now let's see how to write mathematical equation which can be used either inside the non-inline equation enrollment or inside the inline equation. And along with this, we will discuss about the shortcut key that can be used to quickly write the expressions. So here is a case where I want to express my a plus b the whole square, and in order to use this superscript, I have to use this caret symbol along with a number 2 within this curly braces, okay, and the way to get this caret symbol along with the curly braces is by using this shortcut key, which is Ctrl Shift U for upper. And similarly, if I want to have a suffix with x, then I need an underscore symbol along with a curly braces around this x. So the shortcut key to get this underscore along with this curly braces is this Ctrl Shift and D for the down, okay. Now say for example we are working with a vector mathematical expression, then if you want to have something like a dot b vectors, and that is nothing but equal to the magnitude of a with the magnitude of b along with the cosine theta. So in order to write this mathematical expression, we have to write down this entire line, which is backslash overline with a, such that it creates a line at the top of the letter A, and C dot would represent the dot, and again backslash with overline of B will create a kind of overline over this vector B, and again these are the commands that we generally use in order to create this set of things. Now, as you could already see, there are a lot of commands to define these symbols, and I would advise you to use the following links while writing the equation. While the first link gives a list of commands to write the equations, and the second link provides more enrollment that one can use while writing advanced mathematical expressions. So now let's focus on two major topics. One is glossary, the other one is acronym. First, let me show what does these topics really mean for us while writing a project report. So glossaries. There are situations where you might want to use some symbols or constants like c, tau, epsilon, etc. while writing equations. Say for example, you want to have an equation like E equals to mc square, where the c represents the speed of light, and you want to mention the constant c and its description of speed of light under the list of symbols page in your report. So this is where the glossary really mean for us. Okay, so the glossaries are generally used with some sort of equations or the expressions when we try to define them. The next comes the acronyms. The acronyms are nothing but the abbreviations or short forms like IC for integrated circuits, FDTT for frequency difference time domain, and you may be in need of these abbreviations to be used throughout the report, and also want to mention it under the list of abbreviations page in your report, such that the readers of your report knows what these abbreviations are. Hope you have got enough knowledge from the above discussion, and now I will introduce some set of enrollments and compilation command along with the compilation procedure to reflect the same in your report. But before that, in case your report has no abbreviations or no symbols, then you have to comment few lines in the main.tex file. So in the first case, if you don't want any abbreviations in your document, then you have to comment these two lines, which is \new page and then the print glossary. You can use this Control T to comment those two lines such that it doesn't create any sort of abbreviations for you. Now, similarly, if you don't have any symbols and you don't want to appear this list of symbols page, then you have to comment the other two lines with Control T. Okay, and if you want to uncomment those two lines, then you can use this Control U to uncomment these lines. Okay, yeah. Okay, so this remaining part of the video is for the people who want to define the symbols and abbreviations in their report, and also for people who are interested in knowing about it. So basically, both those glossaries and acronyms have some commonalities, and will be using a package known as glossaries to achieve these settings. So maybe I can split these commands from this glossary package into three categories. The first one is the definition commands, the second one is the display commands, and the third one is the compilation commands. The definition commands are generally added to the preamble section, but we will use a separate file to store the definitions, and the file is named as glossaries.tex file and is being placed under the cover page directory in the version 2.0 template. So maybe in the next version, which is version 3.0, this glossaries.tex file will be placed under the auxiliary file folder. And having these definitions in a separate file in general will help us to maintain the main.tex file from being cluttered. The next, the display commands are used inside the content section to display the glossaries and acronyms inside the document. And the third is the compilation command, is meant to create some auxiliary files which will be used by the LaTeX compiler to display the definitions inside the PDF. So this command, in short, reads out the definition from the glossaries.tex file and creates or updates the auxiliary file. Now let's look at the syntax of the definition commands along with an example. So inside this glossary.tex file, one can define a new glossary with this following syntax, where the first parameter or the first curly braces defines a reference name, and then the next field, which is the name field, along with the symbol that you want to have, probably the tau, or it can be even your C or epsilon, whatever the symbol that you want to define could be specified over here with an inline $sign symbols, in case if you are using any sort of symbols here. Okay, and the next one is the description. So what does this exact symbol basically represents is what we have to mention under the description field. And the third one is the type, which we don't want to change. We will be leaving this type as default, what has been mentioned in your template. So as an example, let me try to create a reference name, just RC, and tau is the symbol that I want to use for it. So I've just put this tau definition inside this inline equation $sign, and followed by that I want to describe that the tau describes the time constant of my circuit, and that is what been mentioned here. And the type that I've mentioned before is supposed to be symbol list, and one should not modify this definition until you know what you're doing out of it. Okay, so the new glossary command helps us to define the symbol tau inside the document and also places the description under the list of symbol page automatically. And here the reference name you define in the first curly braces will create a reference name, which is similar to the label command as we discussed earlier. So we'll be using this reference name, which in this case the RC, inside the report to display them later. So next, this new acronym command helps us to create a reference name which you define in the first curly braces, and the next two curly braces defines the short form and its expanded form here. So here is a case where I've defined the reference name as IC, and I just want to write the short form in terms of capital I and C, and the expanded form of it is nothing but integrated circuits. So note, the reference names in both the examples I've used the small letters, which in general need not to be in small letters. This means you can even use capital letters to create the reference names, but I generally prefer to use small letters for the reference names, which helps us to avoid using shift key or turning on this caps lock to write the reference number inside the document. So in a way, having this reference name in small letters often helps me in typing process. This is just a tip for you, in case if you want you can follow that. Now let's see the set of commands that you can use inside this content section, and that will help us to display the acronyms and glossaries inside the PDF file. The command that we will be using is this GLS along with the reference name that we have created, either using new glossaries or new acronym commands that we discussed before. So this single command is the one that you need to bring both the acronym and the glossary definitions inside your document. And here is a case when I use this GLS RC in my document, it reflects this tau symbol in my report, whereas whenever I use this GLS IC, then first time it displays the integrated circuits, the expanded form of the acronym along with the short form inside the bracket. But after then, when you use from the first instance, when it goes to the second instance, it just puts only the short form notation, which is the capital IC. Okay. Of course, there are different variants of GLS commands like GLS PL for adding plurals, and GLS with capital G, and ACR full and ACR short, etc. Students who wants to know more can check the following link. And as a final step, to bring the acronyms and glossaries to life in your report, you need to run a compiler command. So firstly, this compiler command have to be set before you actually use them. So once you set in your LaTeX editor, which is the tech maker, it will be there in your machine until either you reinstall the LaTeX editor or you change your PC or a laptop, it will be there. Okay. So now let me demonstrate how to set this compiler command in the tech maker. So inside the tech maker, you can just go to the user menu and then user commands and go to the edit user command option. So in the first command, you can reflect these settings, wherein under the menu items, you can just type in this make glossaries, and under the command section, ensure that you have this particular command reflected exactly the same. Okay. So once this command has been set, this will be there in your machine until otherwise you either uninstall or change your PC. The next comes the run procedure. So after setting this compiler command, you are ready to run this compiler command, which will only create the auxiliary file for the LaTeX to read out your glossaries and acronyms. So whenever you add any new glossaries or acronyms in the glossary.tex file, you have to run this command of make glossaries, or you can use the shortcut key, which is Alt Shift F1, okay, which is the command that you need to run it. And once you run this command, then this command will basically create an auxiliary file for you, and then followed by this command, you have to run this quick build, or you can use the shortcut key F1 to make this PDF LaTeX compiler to read those auxiliary file information and then put it onto your document. Okay, so now let me combine everything that we have learned in this video, and I'll be demonstrating how it works in the next video. Thank you.